Students, today we are going to discuss NEET 2020 remaining questions. This is part 2. So, see this question. Two bodies of mass 4 kg and 6 kg are held tied to ends of a massless string. The spring passes over a pulley as shown in figure. The acceleration of the system in terms of g. Acceleration of the system in terms of g. Here there are the 4 options are given. So there is a direct formula to solve this problem. That shortcut formula is difference in masses. So this is m1, this is m2. Difference in masses, m2 minus m1 by sum of the masses, m2 plus m1 into g. This is the shortcut formula. This is very useful in entrance examinations. So A is equal to m2 minus m1, 6 minus 4 by 6 plus 4 into g. So A is equal to 6 minus 4 is equal to 6 plus 4 is equal to 10 into g. So A is equal to how much? G by 5. A is equal to g by 5. So our option is, the correct option is second option, g by 5. So our answer is g by 5. Now let us discuss another question. Here, the mean free path of a gas with a molecular diameter d and nuclear density d can be expressed as. So this is the direct formula asked from kinetic theory of gases. Mean free path means what? The average distance traveled by the molecule between two successive collisions. So that is lambda is equal to 1 by root 2 n pi d square, where n is number density, d is diameter of the molecule. So let us check options, which option is correct. So here the first option is correct. First option is correct. Now another question here. A short electric dipole has diameter of 16 to the power of minus 9 kilometer, and the electric potential due to the dipole at a point at a distance 0.6 centimeters from the center of the dipole situated on a line making 60 degrees with the dipole axis is. Now we want to find out what electric potential. So here this is a dipole. So this is a dipole. So from the center of the dipole at a distance 0.6 meter at an angle 60 degrees is the dipole axis. This is dipole axis. We want to find out what here potential is equal to how much. In the NCERT textbook there is a derivation to find out the potential at any point. So the derivation is V is equal to 1 by 4 pi epsilon naught P cos theta by r square. P cos theta by r square. So V is equal to 1 by 4 pi epsilon naught means how much? 9 into 10 to the power of 9. P, dipole moment. Here they given dipole moment 16 10 to the power of minus 9. 16 into 10 power minus 9. Theta, cos theta. Theta is equal to 60, cos 60 divided by r square, 0.6 into 0.6. 0.6 into 0.6. So V is equal to cos 60 is equal to how much? 1 by 2. 1 by 2 means this is 8 into 9 divided by 36 into 10 power minus 2. 9 4s. Okay. So 2 4s. 2 4s. So here what we get answer, 9 4s are 36, 4 2s are. So that is equal to, here we get 2 into 10 square volts. So V is equal to how much answer we get? 200 volts. 200 volts. So our correct option for this question is option 1, 200 volts. Now let us solve another question. Dimension formula for a stress are. We know that stress is equal to force by area. Okay. So force dimension formula MLT power minus 2 divided by area dimension formula L square. By solving this we get ML minus 1 T minus 2. So our option is ML minus 1 T minus 2, that is equal to option 3. Option 3. So here next problem, the energy required to break one bond in DNA is 10 to the power of minus 20 joules. Find the value in electron volts. Here 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. Right, here 10 to the power of minus 20 into 1 by 1.6 into 10 to the power of minus 19. That is equal to 10 to the power of minus 20 into 10 to the power of 19 divided by 1.6. 1.6. So here 10 to the power of minus 1 by 1.6. So that is equal to here 1 by 16, that is equal to 0.0625. So our option is here, what is our option? Second option. So how much value they given? This is 0.06. 0.06. So that is the correct option. Now there is another problem which is given from the waves. In guitar strings A and B made up of same material are slightly out of tune and produce beats frequency 6 Hz. So these are two guitar strings A and B. Two guitar strings. Whenever they sounded, they produce 6 beat frequency 6 Hz. Right. When the tension B is slightly increased, when the tension B is slightly decreased, tension B is slightly decreased. The beat frequency increases to 7 Hz. The beat frequency increases to how much? 7 Hz. So if the frequency of A is 530 Hz, the original frequency P will be which of the following option? There are two options here. We know that the beat frequency delta n is equal to n1 difference n2. So here there are two options. n1 minus n2 is equal to 6 or n2 minus n1 is equal to 6. n1 means frequency of A, n2 means frequency of B. So we have to choose correct equation. So for that, read the problem. When the tension in the B is slightly decreased, whenever tension decreases, n proportional root t here, tension decreases, frequency also decreases. This frequency also decreases. That means here n1 is subtracted from decreasing value. That means here RHS increases. RHS increases. Here decreasing value is subtracted from n1. That means here this value is decreases. So according to given problem, they given the beat frequency increases to 7 Hz. That means this value, RHS value, increases. So we choose correct equation, that is n1 minus n2 is equal to 6. This is the correct equation. So here n1 means frequency of A. How much they given frequency of A here? 530. 530 minus n2 is equal to 6. So n2 is equal to 530 minus 6, that is equal to 524 Hz. 524 Hz. So what is our correct option here? Correct option is option 1. Correct option is option 1. So next question, the color code of resistance is given below. Here there is a resistance is given. On that resistance there are 4 colors: yellow, violet, brown, gold. The value of resistance and tolerance are. What is the value of resistance and tolerance? To solve this problem, we have to remember one code. What is that one code? PB Roy. BB Roy. BB Roy of Great Britain. Great Britain has very good wife. Has very good wife. First B black 0. Second B brown 1. This is 2. This is 3. Yellow 4. Green 5. Okay. This is blue 6. This is 7. Has very good wife. First 2 colors represents 2 significant figures. 2 significant figures. 2 digits of a resistance. YV. Y means yellow. V means violet. That is 4, 7. Into third color represents decimal multiplier. Decimal multiplier 10 power. Brown. Brown is 1. Brown is 1. And fourth color represents tolerance. That means at what extent that measurement value is errorless. That is called tolerance. Reliable. That is, if this color is gold, tolerance is 5%. If this color is silver, tolerance is 10%. So that is 5%. Our correct option is 470 ohms, 5% tolerance. So what is our correct option here? Third option. Now another problem, which is from wave optics. The Brewster angle IB for an interface shown. Do you know Brewster angle? Whenever light is incident, okay, on a reflecting surface, some portion of light is reflected, some fraction of light is refracted. This is a refracted ray and this is a reflected ray. at what particular angle the reflected light is completely polarized, that a particular angle what we call Brewster angle, IB, Brewster angle. So here that Brewster angle is how much? Mu, there is a relationship between Brewster angle and refractive index of medium. This is tan IB. Mu is equal to tan IB. Tan IB is equal to mu. But here this light ray is going to the medium of refractive index mu. This mu is greater than 1. This mu is greater than 1. That means tan IB is greater than 1. So that means what here? Tan IB is greater than 45 degrees. IB is greater than 45 degrees. If tan IB is equal 1, then IB is equal 45. But here the tan IB is greater than 1. That means IB is greater than 45. So IB is greater than 45 means here we check options. The Brewster angle must be 45 less than IB less than 90. Okay, this is the correct option. So here the capacitance of parallel plate capacitor with air as medium is 6 microfarad. With introduction of dielectric, the capacitance becomes 30 microfarads. The permittivity of the medium is what they given, epsilon naught is equal to 8.85 into 10 to the power of minus 12. So whenever the capacitor of a parallel plate capacitor in air medium, what is the capacity here? 6 C naught is equal to 6 microfarads. 6 microfarads. With introduction of dielectric, the capacity becomes 30 microfarads. 30 microfarads. So here dielectric capacitance becomes 30 microfarads, right? C dash is equal to 30 microfarads. So we know that C dash is equal to C naught into K. K is equal to C dash by C naught. That is equal to 30 microfarads divided by 6 microfarads. That is equal to 5. Okay. Look, K is equal to 5. What is K here? It is the ratio of permittivity of the medium to permittivity of the free space. So epsilon by epsilon naught, that is equal to K, that is equal to, this is also called relative permittivity, that is equal to 5. So epsilon is equal to epsilon naught into 5. So here epsilon is equal to, what is epsilon naught? 8.85 into 10 to the power of minus 12 into 5 into 5. So here 8.85 into 5. 5 5s are 25, 5 8s are 40, 42, 5 8s are 40, 44. That is equal to 44.25 into 10 power minus 12. So this can be written as 0.44 into 10 to the power of minus 10 Coulomb square Newton inverse meter square. So our option is here second option, 10 to the power of minus 10, second option. Now we are going to discuss another problem. What is that another problem here? Find the torque about the origin when a force of 3J Newton acts on a particle whose position vector is 2k meters. That means here r bar is equal to 2k cap, f bar is equal to 3j cap. So what is torque here? Torque is equal to r bar plus f bar. So 2k cap cross 3j cap. 2 into 3 6. K cross j. K cross j is equal to minus I. Minus I. Newton meter. So our option is second option. Minus I. Newton meter. Right. Now another problem given in the NEET examination. A resistance wire is connected in the left gap of meter pitch, balances 10 ohm resistance in the right gap at a point which divides the pitch wire in the ratio 3:2. If the length of the resistance of the wire is 1.5 meters, then the length of the 1 meter of the resistance wire is. So in meter pitch there are two gaps. Okay, so left gap and right gap. So in right gap there is a wire of unknown resistance X. In right gap there is a resistance, that is R. So the two ends is connected to the meter pitch wire. So from center of this bit we connect galvanometer and jockey. Okay. So here this point here, this length is balance 10 ohm resistance, and this point divides this wire 3:2 ratio. 3:2 ratio. Now in meter pitch there is a formula, X by R is equal to 3/2, L1 by L2. Okay. Now X is equal to 3/2 into R. What is the value of resistance here? 10 ohms. So unknown resistance 15 ohms. So now the resistance of this wire is 15 ohms. Okay, 15 ohms. Here the resistance of the length of the resistance of the wire is 1.5 meters. 1.5 meters. The length of the 1 ohm resistance, that means here 15 ohms resistance of a wire length is 1.5 meters. 1.5 meters. Right. 1 ohm resistance of wire has how much length? How much length? So here 1.5, that here 15 divided by 1 is equal to 1.5 divided by X. We want to find out what here the length of the resistance of the 1 ohm resistance. X is equal to 1.5 divided by 15, that is equal to 1 by 10. That is equal to here 1 into 10 to the power of minus 1 meter. That means what here? The length of 1 ohm resistance of wire is 10 to the power of minus 1 meter. 10 to the power of minus 1 meter. Right. Another problem. This theory question based on the transistor. For transistor action, which of the following statement is correct? Number 1, base emitter and collector regions should have same size. So this is wrong. So this is transistor. This is a transistor. So here this is called emitter, this is base, and this is collector. So here for transistor action, which of the following statement is correct? Right. So this is a transistor based question. Transistor has two junctions. One is emitter base junction, and another is base collector junction. Okay, base collector junction. This is PNP transistor. Right. So base emitter and collector regions should have same size. This is wrong. Number 2, both emitter as well as collector junction are forward biased. This is also wrong. Here this emitter base junction is connected in forward bias and the collector base junction is connected in reverse bias. Any transistor, the base region must be very thin and lightly doped. Yes, it is correct. Here in transistor, emitter is heavily doped, base is lightly doped, and the collector is moderately doped. And collector has large in size, emitter has moderate size, base is lightly doped and thin size. Okay, this is option correct. 4th one, base emitter and collector regions should have same doping concentrations. This is wrong. So our option is 3rd option. So next we will discuss another question. The ratio of contributions of made by electric field and magnetic field components to the intensity of electromagnetic wave is. The intensity of electromagnetic wave is depend upon energy density of electric and magnetic fields. The energy density of electric field component is equal to of epsilon naught E square, and also the energy density of magnetic field component is equal to B square by 2 mu naught. Now take ratio UE by UB, energy density of electric field to energy density of magnetic field. So here of epsilon naught E square by B square by 2 mu naught. Okay, right. 2 cancel, UE by UB is equal to what we get here. So we get here E by B whole square, E square by B square, B square by B square into epsilon naught mu naught, epsilon naught mu naught. We know that E by B is equal to C. E square by B square is C square into. So we know that C is equal to 1 by root epsilon naught mu naught. Squaring on both sides. C square is equal to epsilon naught mu naught. This is 1 by C square. Ratio is 1. So these are 1:1 ratio, so that intensity of electromagnetic wave, the ratio of contribution made by electric field and magnetic field components to the intensity of electromagnetic wave also 1:1. So answer is 1:1. So now we will discuss another problem. A charged particle having drift velocity 7.5 into 10 to the power of 4 meter per second in an electric field of 3 into 10 to the power of minus 10 volt per meter, which has a mobility dash. So here to solve this problem, we have to use one formula. What is that formula? Mobility is equal to drift velocity per unit electric field. So this is the basic formula. Drift velocity is nothing but 7.5 into 10 to the power of minus 4 by unit electric field 3 into 10 to the power of minus 10. That is equal to here 2.5 into 10 to the power of 6. So our option is option number 1, 2.5 10 to the power of 6. So let us discuss another problem. A spherical conductor of radius 10 centimeter has a charge 3.2 10 to the power of minus 7 coulombs distributed uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? So this is a spherical conductor. Okay, and the charge is distributed uniformly over its surface uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? Electric field. So we know that formula, electric field is equal to 1 by 4 pi epsilon naught to q by r square. U is equal to 1 by 4 pi epsilon naught means how much? 9 into 10 to the power of 9 into q 3.2 into 10 power minus 7 by r square 15 into 15 10 to the power of minus 4. Why we write like that 15 centimeters? Centimeter should be converted into meters. Okay, right. So here 9 into 3.2. 9 into 3.2 is 28.8. 15 into 15, 225 into 10 to the power of here 13, 10 to the power of minus 7, 10 to the power of 6. So E equal to this is whenever we divide this equation we get 0.128 into 10 to the power of 6. So E equal to 1.28 into 10 to the power of 5 Newton per Coulomb. So our option is here 1.28 into 10 to the power of 5 coulombs. That means answer 1. This is correct option. Now another problem is, this is question is asked on the basis of significant figures. Taking into account of significant figures, what is the value of 9.99 minus 0.0099? Without doing any subtraction, we can solve this problem. Option 1. Why? How we select option 1? According to subtraction rules, first we have to find out decimal places, least decimal number. So here 2 decimal numbers, here 4 decimal numbers. So answer should be in least decimals. So here this is 4 decimals, this has 1 decimal, this is 3 decimals. So in the problem, how many least decimals are there? 2 least decimals. So our option is 9.98. This is the least decimal, 9.98. Right. Next, another problem. In Young double slit experiment, the separation between coherent sources is half and the distance of the screen from the coherent sources is double. Then fringe width becomes. So here this is setup of Young double slit experiment. This is S1 source, S2 source, and this is the screen, and this is the distance between source and slits, and this is the separation. D is the separation between the 2 slits. So we know that fringe width beta is equal to lambda d by t. Okay. Separation between the coherent sources is half. That means here beta dash is equal to lambda into, on distance of the screen from the coherent source doubled, that is 2d by d by 2. So beta dash is equal to how much here? 4 into lambda d by t. So beta dash is equal to 4 beta. That means here fringe width is increases by 4 times. Fringe width is increased by 4 times. This is the correct option. Right. Another problem. 2 cylinders A and B of equal capacity are connected to each other via stopcock. A contains an ideal gas at a standard temperature and pressure. B is completely evacuated. The entire system is thermally isolated. The stopcock is suddenly open. Then the process is. So this is cylinder A. Okay, and this is cylinder B. This is the stopcock. Here the gas is A is filled with the gas. Okay. B is completely evacuated and it is thermally isolated. The system is thermally isolated. Whenever this stopcock is suddenly opened, then what happens? The gas expands. Okay. This expansion is called free expansion, but this expansion of gas in thermally isolated system, and this cock is opened suddenly. So we can conclude that when the gas expands suddenly, it rushes into the evacuated chamber very fast, and this is thermally isolated system, so that this expansion is called adiabatic expansion. This expansion is called adiabatic expansion. So our option is adiabatic. And this is a quick process. So there is no time to exchange heat between the system and surroundings, and also this is thermally isolated cylinders. So 100% we say that this is adiabatic process. So another problem is the energy equivalent to 0.5 grams of a substance is, simple formula, according to Einstein equation, E is equal to mc square. So E equal to m means 0.5 grams, 0.5 into 10 to the power of minus 3 kilograms, c square 3 into 10 to the power of 8 whole square. So E is equal to, here 0.5 into 10 to the power of minus 3, 9 into 10 to the power of 16. So 4.5 into 10 to the power of 13 joules. 4.5 into 10 to the power of 13 joules. So our correct option is option 1. Okay, right. Another problem here. A capillary tube of radius r is immersed in a water. So this is a capillary tube whose radius is nothing but how much? R. Capillary tube. Okay, immersed in a water. So this is immersed in a water. Then what happens? Water rages in the tube is up to height h. The mass of the water in a capillary tube is 5 grams. This is the mass of the water. This is 5 grams. Another capillary tube of radius 2r is immersed in a water. The mass of the water that will rages in this tube is. So another capillary tube which is double the radius of first tube, that is immersed in a water. Okay, how much mass of the water that will rise in this tube? We want to find out mass. So this capillary tube area of cross section is in circular shape. Okay, so this is the height h. We know that mass is equal to, density is equal to mass by volume. Mass is equal to volume into density. Volume into density. Right. Mass is equal to volume into. Volume is equal to how much? The circular shape is pi r square and height is h. Pi r square into h into d, density of the water. Density of the water. So here we know that formula T is equal to HR dg by 2 cos theta. So here T constant, D constant, G constant, theta constant. HR is equal to constant. So H is inversely proportional to 1 by R. H is inversely proportional to 1 by R. Right. Now here we are going to discuss how much mass of the water is rages in a second tube. Yeah, second tube. Right. Now we derive the relation between mass and radius and h. Here m is directly proportional to r square into h. m1 by m2 is equal to r1 square by r2 square into h 1 by H2. Okay. Now we want to find out M2. So here M1 is equal to 5 grams. M2, we want to find out M2. R1 square, that is R square. R2 square, that is 4R square, into here H1 is equal to how much? H1 is equal to, so H1 by H2, that is equal here H1 by H2 is equal, we write R2 by R1. There is inverse relationship between H and R. So R2 means here 2R, but R1 means R2 by R1, R. Okay, this R cancel, R square cancel. M2 is equal to 4 into 5, that is equal to, here what is the answer of this question? 4 into 5, that is equal to, answer is 4 R2 square, 4R square, 20 grams. 20 grams. So here this is not 20 grams here, this RR cancel, 2 ones are 2 twos are. So here M2 is equal to, we get here 5 into 2, that is equal to 10 grams. So what is our correct option here? This is 10 grams. 10 grams is the correct option of this answer. Right. Another problem. What is that another problem here? So a screw gauge has least count 0.01 millimeter and there are 50 divisions in its circular scale. The pitch of the screw gauge is. So we know that formula, least count is equal to pitch of screw by number of head scale divisions. Number of head scale divisions. So what is the least count here? Least count is 0.01 is equal to pitch of screw by number of head scale divisions is equal to how much? 50. Pitch of screw is equal to 50 into 0.01, that is equal to, here 5 into 10 into 0.01, 5 into 0.1, that is equal to 0.5, how much? Millimeters. So our correct option is second option. Second option is correct option of this answer. Right. So another question is, two solids which have negative temperature quotient of resistance R. So we know that the negative temperature quotient alpha is equal to RT minus R0 by R0 into T. For semiconductors, when temperature increases, resistance decreases, conductivity increases, resistance decreases. So alpha is negative. But extremely high temperature, insulators also conduct some current. That means here in insulator more energy gap is more. This is valency band, this is conduction band. Insulators never conduct electricity, no doubt at all. Why? Because there is a large energy gap between valency band and the conduction band. It is impossible to jump electron from valency band to conduction band, but extremely high temperatures, the electron in the valency band jump into the conduction band. In that a few cases, insulator resistance decreases and conductivity increases very small quantity. So in that case also alpha is negative. So our option is insulators and semiconductors. Generally, most of the students think that semiconductors only. But here, if we consider high temperature, some insulator also conduct electricity. The resistance decreases. Right. The average thermal energy for monoatomic gas. The average thermal energy for monoatomic gas. Monoatomic gas means it has 3 degrees of freedom, translation degrees of freedom. It moves along x direction, it moves along y direction, or it moves along z direction. It has a freedom to move along 3 directions. So it has 3 degrees of freedom. So according to equipartition theory, energy is associated in each degree of freedom is half kBT. Okay. So this monoatomic gas has 3 degrees of freedom, so that it has average thermal energy is 3/2 kBT. 3/2 kBT. That means 3 into half kBT. Half kBT. So our answer is option 1. Right. Next question. This question asked from center of mass. The particles of mass 5 kg and 10 kg are attached to the ends of a rigid rod of a length 1 meter. This is length how much? 1 meter. Right. The center of mass of the system from 5 kg particle is nearly at a distance of. This is 5 kg and this is 10 kg. Center of mass is always very near to heavier mass. Suppose center of mass of the system is located here. We want to find out distance of center of mass from 5 kg. So here we take 5 kg mass is at origin. 5 kg mass is at origin. We know that formula xcm is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Here xcm means what? Distance of center of mass from the origin. x1 means distance of first particle from the origin. x2 is distance of the second particle from the origin. Right. Here m1 plus m2. Right. So xcm is equal to distance of center of mass is m1 into 0 plus m2 into d 1 plus m2, m1 plus m2. So xcm is equal to m2, that means 10 into here d is equal to how much? 1 meter by m1 plus m2, 15. So xcm is equal to, we find that 10 by 15, 5 2s are 5 3s are 2 by 3, 2 by 3, 2 by 3 meters. Okay, 2 by 3 meters. So this is 2 by 3. That means here 2 by 3 means answer is given centimeters. 200 by 3. 3 6 18. 3 6. So 200 by 3, that is nearly 67 centimeters. Our option is 67 centimeters. So D is the distance between the two masses. Okay. This is the answer of this question. So next, let us solve another question. They ask, find the correct truth table of the circuit. 4 options are given in the question. So we choose correct option. Choose the correct option. Right. These are the 2 NOT gates. This is NOT gate. So let us give inputs to A and B. A is 0, B is 0. 0 0. This 0 becomes 1. This 0 becomes 1. Okay. This is 1. This is 1. 1 plus 1, 1. Reciprocal of 1 is 0. So 0 answer. A0, B1. This 0 becomes 1. 0 becomes 1. This 1 becomes 0. 1 plus 0, 1. Reciprocal of 1, 0. So answer is 0. Similarly, 1 0. Answer is 0. 1 1. 1 plus 1. 1 becomes 0. 1 becomes 0. 0 plus 0. 0. Reciprocal of 0. Reverse of 0. Maximum 1. This is the correct table. This is the correct truth table of the following question. So here the options are given, or in this question. So what are the options are given in this question? So these are the options are given in the question. So see, 0 0 0, 0 1 0, okay, 1 0 0, 1 1 1. So according to this options, option 4 is correct option. Okay, right.